Right, let's look at a parallel circuit. Now, in a parallel circuit, the current has multiple paths to take. That's what makes a parallel circuit different from a series circuit. In a series circuit, there's only one path for the current to take, but in a parallel, you have multiple paths to choose from. This is our battery, our voltage source, that's positive and that's negative. This is going to be the first resistor, R1. This will be R2, and that's R3. If we look at the conventional current coming out of the top end of the battery, I, when the current gets to this point, some of the current will flow that way and some will flow that way. So the current, we'll say that's I1 is equal to, let's write Ohm's law first, V equals IR, so we know that I is V over R. Okay, I1 is going to be equal to V over R1, okay, because it's going across R1. Now, the rest of the current is going this way. Again, when it gets to this point, it's going to split. Some current's going to go that way, some's going to go that way. Now, when that current splits, then you have I2 is going to flow here, and I3 will flow this way. So I2 is going to be equal to V over R2, and I3 will be equal to V over R3. Now, when they come back together, when this current gets to this point, when this current gets to this point, and this current flows back over here, this current flows over here, it meets this current, and they'll go that way, and this current will meet that current, and they'll flow this way. So you'll have the current that you originally started out with, and that's the conservation law. So you're going to end up with the current that you started with. Now, that means that the total current I is equal to I1 plus I2 plus I3. So the total current, I'll just put IT for total current. IT is going to be equal to, I1 is V over R1, V over R1. I2 is V over R2, and I3 is V over R3. Now, I total, I, is V over R, but this R is the equivalent resistance for this circuit. So I total is equal to the voltage over the equivalent resistance. That's IT. So if I rewrite this, that's just V over REQ. This means that V over REQ is equal to V over R1 plus V over R2 plus V over R3. If we divide every term by the voltage, we end up with 1 over REQ is equal to 1 over R1 plus 1 over R2 plus 1 over R3. And this is how we come up with the equation to determine the equivalent resistance for a parallel circuit. Now, the problem with this is that when you get to the very end, you have to remember to flip this because REQ needs to be in the numerator. So at the end of solving a problem with equivalent resistance, you need to make certain that you deal with that not being in the denominator. The other problem is you might need to find a common denominator between these three terms and then add them.